Welcome dear students. We are on the CEC Gurukul lecture. We are in the series of electronic circuit and we are discussing the various components which are used in the electronic circuit. Today we will discuss about the transducers, which is the one of the important component in the electronic gadgets. So in this lecture we discuss what are transducers, what are type of transducers and how we can prepare these electronic gadgets. First, what is the transducers? How we define, what is the definition of transducers? Transducers basically is a device which convert one form of the energy into the another form of energy. These transducers get the input and present the output in the another form, while an electrical transducers converts one form of energy into an electrical signal. It means we are having a transducers as well as we are having a electrical transducers. Those transducers convert one form of the energy into the electrical signal that are known as electrical transducers. If we give an example of both the transducers and the electrical transducers, then first we take the example of the transducer. We always see that the speaker is said to be a one type of the transducer, as it can change an electrical signal into the sound energy. So speaker is a transducer. If we talk about the electrical transducer, so we take an example of the microphone. Microphone is an electrical transducer because it converts sound energy into an electrical signal. So transducers which convert one form of the energy into the another form of energy. Now we see on the screen the basic schematic diagram of the transducers. One form of the energy converted through the transducer into the another form of energy. Right, we see here that one form of the energy, when electrical transducers are used, then it converts into the electrical signal. Now you see on the bottom that we are having a electrical transducer which is containing the two components. One is the sensor and second is the signal controlling unit. Same form of the energy as an input. So now you see here the one form of energy going to the sensor and the same form of the energy we are getting from the sensor. Then here we are having a signal controlling unit which convert that energy, that an input into the proportional electrical signal. So that is the electrical transducer. Sometimes electrical transducers use a two unit, one is a sensor, a second is a signal controlling unit which convert one form of the energy into the electrical signal. A simple transducer convert the one form of the energy into the another form, and the electrical transducers convert one form of the energy into the electrical signal. That's why they are known as the electrical transducers. The output of the transducers is proportional to the input or measured quantity applied to it. It means we are giving a certain amount of input to the signal and then we get the output in that proportionate we required. Now for instance, if we take the temperature, pressure, light, sound, position and other quantities are converted into their proportional electrical signal, then we use the transducers. Means we convert the sound energy into the electrical signal, then we use the sound transducers. So we can convert the light, pressure, temperature and so many quantities can be converted into the electrical signal. And thermometer, piezoelectric transducers and potentiometer, microphone, etc. These all are the form of the transducers. The transducers uses a sensor and the signal controlling unit to perform the transaction. The sensor senses any changes in the physical quantity or the energy and provides a non-electrical output. It can then convert it into the proportional electrical signal by using the signal controlling unit. It means a transducer uses a two part. First is a sensor which convert the one physical quantity into the another, but it was not an electrical output, but by using the electrical signal unit we convert it into the electrical signal. Next, if we talk about what are the advantages of the signal conversion, there are the various advantages of converting the physical quantity into the electrical signal. Some of them we will discuss. The electrical signal can be easily processed using the various electrical circuits and the microcontroller. Sometimes we require the output in the form of the electrical signal, so we use the transducers. The information can be stored easily in the form of the electrical signal, and that can be reused whenever we need it. Now, the electrical signal can be amplified in a controlled manner, and it can be visually displayed on a scale. Means we can amplify the electrical signal, and we can control the electrical signals. The electrical signal is used to form a user-friendly interface to operate any instrument. It is easy to get the electrical signal output, and then we can save it in the database. The electrical signal is efficiently processed and help in automating a complicated process. Then the complicated process may be easy by using the electrical signal. Now, transducers is generally made of two main components as we discussing. First is the sensor and second is the signal controlling unit. It may be called as sensor or the sensing unit, and transduction or the signal controlling unit. So, a transducer made of two components. You see on the diagram that here both are having a part sensor which take the input, and that it convert it into the non-electrical form of energy. Then this output go into the signal controlling unit, and this signal controlling unit provide the electrical signal in the proportionate which input we are giving to it. So, this is the electrical transducers. The sensor unit is responsible for detecting any change in the physical quantity. So, if we are giving any input and is there any change in the physical quantity, then we use the sensor. That sensor output, which is the non-electrical in nature, goes into the transduction unit, that is a signal process controlling unit, which converts the sensor's output into an electrical signal that is proportional to the input quantity. So, by using the electrical signal controlling unit, we can get the desired output in the given input signals. Right. Now, what are the types of transducers? There are various types of transducers which are classified on the basis of various characteristics, as what are where we are using this transducer, where we can having this application in any field. So, on the basis of that, these type of transducers are defined. So, we classified the transducers on the basis of its characteristics. If we talk about the power sources, based on the power sources, transducers can be divided into two types, and based on the external power being used. Number one is the active transducers, number two is the passive transducers. If we differentiate or if we classify the transducers on the basis of power source which is given externally, then it is defined by the two types. Number one is the active transducer, second is the passive transducers. What are the active transducer? Which does not require any external power source to the work. It utilizes the energy from the one physical change itself to operate and produce a proportional electrical signal. Automatically it uses the energy from the physical changes. So, various physical quantities can be converted into an electrical signal. So, no external output, no external power sources is required for the output signal, but it utilizes the energy from its physical changes. So, this type of transducers are known as the active transducers. If we take the example, then we take the photovoltaic cell. That photovoltaic cell can convert the light energy into the electrical signal without the use of any external power source. Similarly, piezoelectric crystal is sensitive to the pressure changes and that convert the pressure into the electrical energy without any external power. Means in the photovoltaic cell, we use the light energy which converted into the electrical signal. In the piezoelectric crystals, we use the pressure which changes and that converts the pressure into the electrical signal. It means here we are not using any external power. But in case of the passive transducers, we use the external power sources to operate these passive transducers. It converts the physical quantity into the proportional resistance, capacitance or inductance that is further converted into the electrical signal using an external power source. Means in the passive transducers, we use the external power sources that will be used to convert the physical quantity into the proportional resistance, capacitance, and then further it converted into the electrical signal. So passive and active transducer where we are not using the external power sources, but the passive where we are using the external power sources to get the electrical output signal. Now, they are the transducers that work of these principles are passive transducers, such as if you take the example of this passive transducer, then we will take the potentiometer. Potentiometer vary the resistance with a change in the position or length that is converted into the voltage and current using a power supply. So, potentiometer is an example of the passive transducers. Now, you see here on the screen that one form of the energy converted into the electrical signal, that is the active transducer, but in case of the passive transducer, you see power sources are used to convert the one form of the energy into the another electrical signal. Right, based upon the output conversion, we can differentiate or we can divide the transducer into the various types. Number first is the primary transducer. What are the primary transducer? That transducer which convert the physical quantity into the mechanical signal. If that converts the physical quantity, means any physical quantity, temperature, pressure, that can be converted into the mechanical signal. They induce mechanical as well as the mechanical devices that can be converted into, and that signal we can take on the mechanical devices. The output of the primary transducer is further converted into the secondary transducers. Now you see here that first the physical quantities goes into the primary transducers, then it convert into the mechanical signal. After that, this mechanical signal pass into the secondary transducers, and that will give the electrical signal. Means both the transducers are used. One first convert the physical quantity into the mechanical signal, that mechanical signal converted into the electrical signal by using the secondary transducer. So both the transducers are used to convert the one input to the another input. So the secondary transducer converts the mechanical signal of the primary transducer into the electrical signal. They are electrical circuits whose output signal magnitude is proportional to the mechanical signal. Now on the basis of the input and on the basis of the signal we are giving, the transducers are divided into two parts. Number one is analog and the digital transducers. What are the analog transducers? This type of transducers converts the physical quantity into the electrical signal into the in the form of the analog signal. Right, means the output is in the form of the analog. So its magnitude is continuous with the time. The output is the continuous function in case of the analog transducer. If you take the examples of the analog transducers are the thermistor and the thermocouple, which measure the temperature. So analog transducer which gives the output in the continuous manner with respect to the time. An example of this type of analog transducers are the thermistor and the thermocouple, which measure the temperature. Means which convert the temperature which is a physical quantity into the electrical signal form. So, a piezoelectric sensor for the pressure measurement. So, one form of the another form by using the analog, which is in the which is continuous with respect to the time, and which is giving the output function continuous manner. Second type is the digital transducer. As we know, digital 0 and 1, we use the binary numbers, and output is in the in and off type. So, a digital transducer which converts the physical quantity into electrical signal, and the output is in the digital in nature. The output signal discrete and non-continuous, both in the magnitude and time. So, here we are getting the discrete output, which is in the form of the 0 and 1. The output signal is the binary form 1 or 0, which is called the bits. And example of this is the microcontroller. It is used for interfacing the transducer directly with a microcontroller. So, analog and digital transducers are used. Now, see on the screen we are seeing that the continuous output, and in the digital electrical signal we are getting the discrete output in the digital form 0 and 1. Physical quantity passes into the analog transducer. The output is the continuous electrical signal, that is analog signal, and then the primary and the physical quantity that goes into the digital transducer, and the output is a digital electrical transducer. We are having the inverse transducers also. So, we discuss the transducers and the inverse transducers. What are the transducer? We know the one form of the energy converted into the physical, from the one form of the physical quantity into the electrical signal, such as the thermistor and the microphone you see here. And what are the inverse transducer? Which that is a device which convert the electrical energy into any other form of the energy. As we name suggests, as its function is opposite of the transducer. For example, we can take the inverse transducers are the speaker, screen and servo motors. These give the inverse output to the transducer. Now, another type of the transducers we can define on the basis of the quantity which we are measuring. As we discussed that we are using the temperature, we convert it in the electrical signal. So, what type of transducers we use? We use a thermocouple, and that type of transducer temperature transducers. For example, here we are distinguishing the transducer on the basis of the physical quantity. Like here we are converting the temperature into the electrical signal. So, we use the temperature transducers, and example of this type of transducers is the thermocouple, and the pressure transducer, that is the diaphragm, and displacement transducer, that is LVDT, oscillator transducers, flow transducer, inductive transducers. So, these are the type of transducers which are defined on the basis of the quantity which we are measuring. Another type of transducer which based upon the principle of operation are the photovoltaic cell, solar cell, which converts the light energy or sunlight into the electrical signal and electrical energy. And the next is a piezoelectric transducer, where it uses the pressure and convert it into the another form of the energy. Next is the chemical transducers, mutual induction, electromagnetic Hall effect, where we use the magnetic field, and next is the photoconductor. So, these are type of transducer based upon the principle of the operation. We will discuss one by one in a very brief manner about the what is this type of transducer and what is the function of these transducers. So, photovoltaic cell is an active transducer which converts the light energy into the electrical energy, and we all know that it is made of the semiconductor material which is having a PN junction. So, when the light particles enters in the junction, it energizes the junctions and releases the current into conducting load, and that current is known as a photoelectric current. So, here we see that light energy converted into the electrical in the form of the electrical energy. So you see that photovoltaic cell is the active transducer, and it made of semiconductor, and that it convert the light energy into the electrical energy. And it is also known as a solar cell when we use the solar light. That's why solar cell are made of this. So solar cell is one type of the transducer which are used to convert the solar energy into the electrical energy. So solar energy into the electrical energy to the power to the power electrical equipment, and they are the source of the green energy. Nowadays we are mostly use the solar cells for converting the sunlight into the electrical signal. So next is the photoconductor transducer. Same as we discuss the photoconductor, where we use the light, and it is based upon the light dependent resistors. So photoconductor transducer is a device whose conductivity depends upon the light intensity, how much light is falling upon the surface of the metal, and then what type of output, how strong signal we are getting on the basis, which depends upon the light intensity. And for this LDR is used. LDR is a light dependent resistor, is a photoconductor whose conductivity increases with an increase in the intensity of the light. As the light increases, conductivity will increase. So LDR can be used to convert the light intensity into the electrical signal. So another type is the photoconductor transducer. Next is the piezoelectric transducers, which are used to convert the pressure signal into the, or pressure or force or the strain, or convert into the electrical signal. So piezoelectric transducer work on the principle of the piezoelectric effect, and it generates the electrical energy that is proportional to the pressure, force and strain applied on it. So there are various type of material that produce the piezoelectric effect, or one of the most example are the quartz crystal made from the silicon oxide. So piezoelectric transducers are prepared by using the quartz and quartz crystal. So plates are prepared. It produces a charge on its surface when a force is applied on it, and that charge can be utilized by connecting electrodes to its surface. So this and that measure the change in the pressure, acceleration and etc. You see how much pressure we are giving, on the basis of that output of the signal we will get. So the piezoelectric transducer used for measuring the change in the pressure, acceleration etc. They are used in the automatic door for the sensing footsteps. As you see in the malls, the doors open automatically, and this type of transducers are used there in preparation of the doors. So they are used in the automatic doors for sensing footstep. It is also used in a lighter to generate the necessary sparks to ignite the fuel. So piezoelectric transducers are used in preparing the lighter and the automatic doors. Next is electromagnetic induction. What are the electromagnetic induction? This and inductive transducers which work upon the electromagnetic induction, that measure the change in the inductance between the two coil, and this can be done by either the self inductance or mutual induction. So a movable core is used between the coils of the transducers to vary the inductance between them. So physical quantities such as displacement, force, torque, acceleration can be measured by using this electromagnetic induction. We will further discuss the other type of the transducer in the next lecture. Thank you.